Welcome to the Engineering Room, a monthly series of long-form conversations with influential people from the world of software. The Engineering Room series is sponsored by Equal Experts, and I'd like to thank them for their ongoing support. So if you'd like some help building some great software or interested in finding a great place to work, do check their links out there in the description below. My guest today is a consultant, coach, trainer, analyst and developer. And I think I first met him as an organiser of one of the UK's best software conferences. His name is most closely associated, I think, with behaviour-driven development. And he's been a long-term contributor to the Cucumber open source project, which is one of the most widely used frameworks for BDD. He's also written several books on this and other software topics, including the BDD Books series, along with a co-author, and he has the first chapter in 97 Things Every Programmer Should Know. He's also a blogger, a regular conference speaker, as well as a conference organiser, and also helps to run a charity via the very excellent Cyber-Dojo.org site to help teach people test-driven development, and also helps children to learn to code. So please welcome Seb Rose.
Thanks very much, Dave. Just a minor little correction. So although I've been involved with Cucumber and have contributed to it, I'm not a major contributor to Cucumber. I've been someone who proselytizes BDD and Cucumber and promotes it. But if you look at my commits on the open source on the repo, you'll find they are few and far between.
Fair enough. So it's nevertheless, even if you're not writing the code, that's quite a list. You're a pretty busy man. What else did I miss?
I'm on the committee of the Edinburgh branch of the BCS, and we invited you to come and speak here a number of years ago, which was great. I've been involved with the first Lego League through the BCS as well for a while. And I'm currently a director of SoCraTes UK and help organise the SoCraTes Unconference, which happens in the first weekend of June every year. And we're just about to do a kickoff. And in fact, by the time this goes live, we should have already started announcing when next year's SoCraTes conference is going to take place, and we're always looking for people to come along and join in the unconference, but also because it's a community venture, not for profit, etc., we're always looking for people to help organize it. So this is a sort of call to action right at the beginning of a long form conversation.
Cool. We'll put some links in the description underneath to point people in the right direction for that stuff.
Great.
I think certainly when I think of you and your work, probably because I don't know you very well, but I tend to think primarily of BDD, and I was kind of peripherally involved in the creation of BDD from the outskirts while Dan North and Chris Matz were working on the ideas. So I'm really interested in how you got involved, how you perceive it, and why it's worth all of this effort that you put into it.
Yeah, well, so I wasn't there at the beginning. My background is fairly traditional. I went to university in Edinburgh starting in 1983, and I did computer science and electronics, and then I went and got involved in a few jobs after I graduated, and went from C to C++. And I was very much a contractor, cutting code, progressing into architecture, and just generally a bum on a seat as a member of a team. And when my daughter was born, so my first child, I thought that contracting was maybe a bit too dodgy. I don't know whether anybody who's listening has been through that process. You always think about the next job, and I don't know why we think this, but we somehow think that a permanent job is more steady than a contract job. It's not, just FYI, just in case you didn't realize it, you're probably likely to be kept on as a contractor more likely than you are to be kept on as a permie. But anyway, I went permie with IBM, and at that point I started looking much more deeply into test-driven development. I'd started looking at it during contracting when I was working with Bank of Scotland, but at IBM I really got into it, and I came across Cucumber, and it just seemed like immediately I thought, why have I never heard of this before? Why is it not being used everywhere? And at that point, I was working in Java, and there was no Cucumber for Java. There was a hideous thing that Goiko Ajek had done for trying to get JRuby running and getting Cucumber to run in Java environments. And I never really got it working very well. And at that point, I started communicating with Aslak, trying to work out what way to go forward. Didn't get much traction at Amazon. But I didn't get traction at IBM. Then I moved to Amazon and didn't get much traction at Amazon. And then I went back to being consultant, and I was working with an insurance company, and they had some real issues with testing new versions of their insurance rates. This was back in the early 2000s, I guess, and no, 2010, around there. And there was a change in the UK law to do with gender discrimination. So in the past, before that time, insurance companies were allowed to give women cheaper car insurance than men, because of course women are safer drivers, as everybody knows. But this law changed, and it weren't allowed to discriminate by changing prices. And so they knew that when this law came in, there was going to be massive competition in the marketplace. As it came in, people were going to be tweaking their rates on a practically daily basis to try and make sure that they kept their market share. And they had a turnaround time of testing a new rate pack of around 6 weeks. That's not very agile. That wasn't going to help them keep their market share. And so I said, well, we could do this with Cucumber. You know, we could write Cucumber scripts. We could work with your actuaries, and your actuaries could write their test cases in a spreadsheet, which is what they love doing. The Cucumber scripts could read the spreadsheet, run the tests, and you get your result in about half an hour. And it just changed their whole business model. Now, since then, I've spent a lot of my career in BDD trying to explain that what I did there was not BDD. What I did for that insurance company was harness the power of a business readable scripting language to do fast turnaround testing. But the fact that I was engaging with Cucumber, was engaging with Aslak, and I then met Matt Wynn, who was Aslak's co-lead of the Cucumber project for a long time, at a conference in Edinburgh. It was at that point that I started beginning to understand that behavior-driven development starts way before automation, actually has nothing to do with scripting, and really has very little to do with Cucumber either these days. So behavior-driven development and Cucumber, I now think of as almost as two separate things.
Well, that's interesting. So certainly the way that I was thinking of BDD at the start was very different to where it ended up. I think partly as a result of Cucumber, because we started off trying to fix TDD. we were trying to focus on the behavior and trying to get to the high ground of test-driven development advantages much earlier in the process. It's interesting what you're saying about your first use of BDD wasn't really BDD, because that's another side effect. I think one of the techniques of BDD is this idea of creating a domain-specific language that makes it easy to express useful requirements, and once you've got one of those DSLs, it's a really handy tool for other things.
Yeah.
And I often see it in that kind of light too, as a way of more effectively being able to, in regression situations, go back and kind of backfill some of the testing legacy. But so can you describe a little bit of how, that description in a bit more that distinction that you make in a bit more detail between those things?
Yeah, so I guess the thing I'm going to go back even a bit further. Okay.
Yeah.
So the first project that I worked on when I graduated was called the Recursive project. I will give you a link to an article that I wrote about that. But the Recursive project was a TLDR, a complete failure. It was run by a Glasgow HiFi company called Lin. So any audiophiles on listening will know who Lin are. And they wanted to automate a new warehouse that they'd built. And they'd commissioned Professor David Harland to write some software to automate their system. And he wrote the software, demoed it, they loved it. And then he said, but none of the hardware available today is sufficiently powerful to run it in efficiently enough. So somehow he conned them into setting up a company to develop their own object-oriented chipset called the Recursive. Mm-hmm. And his the boat to which he's nailed his sail was complex instruction set computing. Now, everyone listening to this podcast will know that that's not the approach that won the computing war, right? So every chipset out there at the moment is a RISC-reduced instruction set computing. He was going for complex instruction set computing, so you could develop subroutines or in microcode that could encapsulate complex operations. And in a way, there's a parallel there to how BDD practitioners advise people to use Gherkin. So what we're trying to do is develop that high level domain specific language that describes concisely, potentially really complex operations. The classic example from pretty much every BDD tutorial you look at will be login, right? Mm-hmm. So when I log in, so you don't want to say, I click this link, I click the login button, I enter my username, I enter my password, I click the submit button, I say I'm not a robot, or get my two-factor authentication to enter it. You don't want to say all that. You just want to say, given that I've logged in, and that might be an arbitrarily complex operation. However, you look at 95% of the Gherkin scripts that are written, and they are a very low level of abstraction. They will go through every single mechanistic step. They don't expect intention. And that's something that we continually try and push people away from. We ask them to develop the understanding, and from that understanding of their domain, you can then, in conversation with other stakeholders and other people on the team, you can develop that domain-specific language. And at that point, you're in a place where you can specify your requirements in little scenarios, as they're called, but in examples of how it's being used. And those examples can be very brief. And at which point, I have to plug the fact that Gaspar and I, in our BDD Books series, created the acronym BRIEF to describe how you can get to the point that arbitrarily complex operations can be described and specified in business readable language in 5 lines or fewer. Because the last thing you want is to go from your 6-month big design up front and having 300 pages of specification to having feature files with 150 scenarios in them, each of which is 50 lines long. Nobody's going to read it, and no one's ever going to spot the mistakes that are inevitably there.
And they're going to be more coupled, more tied to whatever your implementation is as a side effect of doing it that way. It's one of the huge advantages of. I think in general, I hadn't really thought between the similarity of kind of CISC chip design and BDD before, but it makes complete sense to me. I remember the era when people were trying to do the kind of application specific CPUs, as a result, there were several moves to build Java CPUs, I remember, amongst other things. But that idea of abstraction, and I wonder often whether that's one of the things that people find difficult about software design. I've said a few times that as a consultant going into other people's organizations, it's not that I often see bad design. The most common thing that I see, no design at all. And people don't think in these sorts of terms of using techniques like abstraction to kind of raise the level, so you can kind of talk about something precisely, accurately, without going into all of the nerdy detail that you don't really care about. That's just the plumbing. The details of all of those other things, as you said with the login example, they're important, they need to be there, but they're a side effect of what the user wants, which is to get access to the things that they want to use. And so specifying it that way seems important to me.
Yeah, although we have to caveat that by saying that we need to specify things using an abstract from a high level of abstraction, because otherwise you get bogged down in all the detail. But you also need to specify the low level aspects. So when you're actually designing login, you're going to need absolutely going, well, you could do it through TFA, you could be using a token, it might be with fingerprint recognition.
Yeah.
But you don't need to do that every time you're talking about an example that involves login. Only when you're actually trying to make sure that you're designing the login process correctly do you need to go down into the weeds. And I think it's basically like the many layers of the onion, isn't it? So you start from, if you do take it from an outside-in approach, well, you start off by thinking about the journeys that you're going to go through. You may be doing something like user story mapping, and you're discussing these with your users. But then at each point that you get to a significant piece of business logic, well, then we have to dive in. It's just you don't have to keep repeating all of that detail in all of your other examples and scenarios.
And I think that fractal nature of it is one of the things that we were touching on earlier when I was saying where we started from when we were talking about BDD was the lower level stuff. It was the, if I'm writing a list, what's the behavior of a list from the user's point of view? That is a programmer using a list class or whatever else. That's still behavioral. You still want to express the behavior in your tests rather than the implementation detail that gets in the way. So you want to be able to say, if I'm adding something to a list, the things are added in order, and I can get them out on the index that that it was added at, and those are behaviors that say nothing at all about the implementation detail inside. And it's that kind of abstraction that gives us the tool that you were talking about, to being able to talk at the business level. Given that the user's logged in, now they can do these things. It's kind of the same sort of thing, but it's fractal. It's operating at a different scale, it seems to me.
Yes, it absolutely is. This is kind of a tangent here, but maybe topical. I wonder how the Nats defect crept in, where they had managed to have, according to the papers yesterday, they managed to have 2 waypoints not in the UK with the same name. Now,
yes,
you would think that safety critical software systems would have recognized that unique naming was quite a useful property to have, and yet you would think that would have cropped up if you'd had any sort of domain language that you could express abstract concepts in.
Yeah, and the one of the huge advantages, I think, of I tend to use the word specification a lot when I'm talking about what it is that we're creating rather than tests, because treating them as specifications, I think, puts you more into the mindset of imagining those scenarios that might be problematic, the kind of engineering thinking of how could this possibly go wrong? Well, all these ways. So let's think about what we want to do when it's going wrong in those ways. And I think it drives you to that kind of thinking, which I certainly find hugely more productive and a lot safer in the systems that I build.
Yes. There's still, though, isn't there, it's a subliminal belief that what developers should be doing is hitting the keyboard and typing code, and
Yeah.
that we should have started typing code. It's like it's redolent of the job adverts that I remember from the 90s and early 2000s, where they used to say must be able to hit the ground running. It basically means we want you to have written half the code, come with your own libraries, and just chug it out, and we're not going to worry about testing or specifications.
Yeah, absolutely, and absolutely 100%. But also, we software developers are often complicit in thinking about our jobs in those terms. You get people, so testing's not my job, and those sorts of pushbacks when you start talking about this way of working. But it seems to I'm talking too much, but you're encouraging me because we're in such strong agreements. But I think that our job is to solve problems for people largely using software. If we can solve the problems without the software, that's still a win. So minimizing the amount of software that we write is probably a good thing.
Well, so I mean, one of my mantras is one that Liz Keogh taught me, which is when you get given a software problem, imagine how you can solve it with an infinite number of pixies. I think she said, an infinite number of small imaginary beings. And once you've imagined how you might solve it like that, then consider which of those imaginary beings could be realized as software, and begin to ping things in. I'm also currently wearing a Lean Agile Scotland t-shirt. I don't know if it's visible. On the back of it is Gold's Law, which basically says that it's a complexity law, which basically says that most complex systems that work invariably evolved out of simple systems that work. And it seems to me that we have a real problem in the world at the moment, that people go straight for the complexity rather than trying to find a simple way, and then having processes, potentially manual processes, to cover the few cases that fall outside of the simple path, and then gradually engineer it, design it so that it can cope with more and more of the corner cases. Because you can go and try and do everything all at once, and 80% of the stuff you do will never be used. Or you can go deal with the 80% that happens all the time, and then have exception process handling to deal with the 20% that don't fit into those. And so we don't appear to be very good at understanding that. It seems to me that the cost of creating and maintaining software, despite the fact that everybody knows it's expensive, is still wildly underestimated. And so people try to solve all the problems all at once for the first release, rather than being able to prioritize the things that will actually deliver the most value the quickest.
I think I'd taken even a slightly harder line than your t-shirt, in that I think that all complex systems start off as a simple system. I can't think of anything complex that sprung fully formed from the mind of some genius. That they evolve and develop over time. Even when you think about Einstein riding on his train and imagining trains going at the speed of light and what that would happen, but that came out of lots and lots and lots of other learning that got him to the point to allow him to think those ideas. And he still didn't get it all right. He was still getting special relativity before he got to get general relativity. So even when we are genuinely talking about a genius, it's not that simple. And it seems to me that the stuff that we've been talking about seem to be some of the tools that can help us all, genius or not, to make progress and do that. People used to talk, I used to think about my approach as being kind of defensive, but it's just incremental. It's just working so you can keep your software in a state where you can safely and easily change it. And BDD, as you described in your story right at the beginning, is a huge win for helping to do that in its regression testing position, readable, understandable regression testing place.
I mean, we've all, anyone who's been involved in testing and has had to go and try and read through I don't know, test scripts out of one of the maybe legacy, but maybe not quite legacy repositories, we'll know that the title of the test script very rarely adequately describes what the test script does. And you wonder why the test script is so long. And then you end up with 30 of them that you're looking at, and you can't work out why you need to run all 30 of them. But you're not confident enough to delete any because there's no one left in the company that knows why they were written. It is in so many ways. We've been talking about quite a lot of different topics in the past 15-20 minutes, but they're all regarding the complexity of systems and how you manage those complexities. And in fact, you go back to some of the early katas that demonstrate TDD, for instance, the bowling game kata, and developers almost always balk at that first test, which returns, I can't remember, nil or whatever it was. Because it's, well, why are you hard coding that? Well, because this is implementing an application that covers a specific case. And now we're going to iteratively and incrementally generalize it. We'll add more tests and we'll add more code to cover different situations. It's a difficult one to get across the first time.
It's exceedingly difficult, and you can kind of understand the reticence to some degree if you're thinking only of writing the code rather than trying to maintain the small steps of incremental change that keep us safe all of the time, which I think is really part of what it is that we're doing.
But there's a tension there, isn't there? Because earlier on, you were talking about how systems aren't designed, and now we're also saying, but really we should evolve software in small steps. And there is to some extent a tension between having a design in mind based on where you want to get to, and also letting the software or letting the specification drive out the software in small steps. That is quite. That's still a tricky thing to explain, and even it's a tricky thing to do.
I agree with you, but I do think that's the huge win for me, and that gets us into other aspects of design. So how do you think that problem is best tackled?
Well, I actually think the tension is a surface level tension rather than a deep tension, because actually the reality is you can come up with the design in advance, but until you've developed the software and really understood the domain, you're never going to know whether that design is going to satisfy the constraints. And equally, as you're developing a software, or even after you've deployed the software, the environment in which it runs is likely to change, and therefore the software will need to change, and potentially the design will have to adapt. So in reality, the way I see it is you can come up with an idea. As you're doing your incremental steps, you work towards solving that solution. The actual specifications that you write as TDD tests are driven to some extent by your understanding of the domain and your initial design. But when you find that you've got it wrong, or there's a complexity that you hadn't considered in advance, or indeed the business situation changes so that you have to modify your design to cope with it, the fact that you have a really good set of specifications that will tell you when you break the software makes it much simpler to modify the implementation of the design, and hence it makes it much simpler to modify the design. So you could start by doing it on one laptop and then move it to a client server configuration, then migrate it to the cloud, and all of these things would be supported by a set of an exhaustive set of test scenarios or specifications, which means that you have to come up with a design to start with so that you convince yourself you understand where you're heading. But when you get to where you thought you were going and discover it's not the right place, all the work that you've done so far is not wasted. You don't have to throw it away. It supports your refactoring towards the design that satisfies your new understanding of the requirements.
I think that idea is one that people that don't practice TDD and argue against it find surprising and counterintuitive. Often one of the pushbacks that I see, and I think I've read some of the stuff that you're writing about some of the common pushbacks a while ago too, saying something similar, is that people assume that tests are going to make it more difficult to change your mind rather than less. So elaborate a little bit further on that and why that's not the case.
Well, I mean, I think this harks back to where we started around the level of abstraction. So if you're writing tests that go, well, I want to call this method with these parameters, and I expect these method calls to happen as a result of this call with these parameters, and then I expect this value to be returned. Yeah, if you want to restructure a system that has tests that look like that, you're going to have a hard time. But if you have a test specifications, your TDD specs written at a higher level of abstraction, where you talk about the behavior that you expect, now the behavior is not changing, or at least in general, most of the behaviors won't change when you change the design, and therefore your tests should carry on working. Of course, there will be some behaviors that will change. Otherwise, why are you changing your design? And in which case, well, of course, you're going to have to rework those specifications, because that was the whole purpose of changing the design in the first place. So, I mean, it's around the coupling of your tests, your implementation. Yes. As long as you can keep those at a sufficiently high level of abstraction, the tests, here we're using specification and tests interchangeably in that. I know that gets confusing, but as long as you can keep those specifications at a high enough level of abstraction, then they should support the evolution of your system design rather than hinder it. However, if you duck down, dive low, you've got very tight coupling between your your specifications and your code. If you've got very very prescriptive mocking or spying going on, then that is a form of coupling. And at that point, now you've got a whole bundle of stuff that will act as a drag to change. So there is some subtlety here. I mean, I guess the trouble is we've got these terms, test-driven development and behavior-driven development. And certainly in the BDD world, there's a belief in many areas of software development that if you use a piece of a tooling framework that uses the words given, when, then you're doing BDD. You're not. And in the TDD world, there's a belief that if you write the test before you write the code, then you're doing TDD. Well, these are both, it's necessary, but not sufficient to be a test-driven developer. You need to have you need to practice. It's like anything, I guess. You need to have some practice. You need to see the fact that if you go down right to the mechanistic level and get very specific about interfaces and return values, and you don't have an abstraction that describes the domain effectively, then you're probably going to get into deep water later on. Whereas if you can come up with those understandings, you can co-create, I would expect, a domain-specific language that describes the behaviors that are needed by your system, then your coupling is at a much higher level, because it's really unlikely that your domain is going to, the domain terms are going to evolve really quickly and have to change massively. Whereas if you go from bubble sort to list sort, that at a low level implementation detail, that could completely change your classes and the methods that you call and the implementation within them.
Absolutely. And that's the magic word coupling, the enemy of all software developers in my mind, or at least the height of achievement is getting the coupling right in your designs, I think. but it is a complicated process, and as you say, this is not an innate skill for anyone. Everybody needs to learn this, and everybody gets better with practice. So I think both. Sorry, you were going to say something.
Well, I was going to use your word practice there to segue onto Cyber-Dojo and give a quick plug to
Oh, I
that
was going to
one
take us there,
place.
but go
Okay,
ahead.
well there you go. Great minds think alike. So test-driven development. Let's start with a position statement. Test-driven development is difficult to do well, but it's quite easy to start learning it. So
Yeah.
it's simple but not easy. So, well, I can never remember which way around it goes, but nonetheless. So my colleague John Jagger, many years ago, to aid his training course, where he trained teams in test-driven development, created a really wonderful online training environment called Cyber-Dojo, which again you'll have a link. It's at cyberdojo.org, and I don't want to go into the details about all the wonderful things it does, but it's a really good free-to-use tool in non-commercial environments for groups of people to all work on the same problem in independent silos and then compare the routes that they took to get to the solution. It comes preloaded with 30 or 40 different languages, with multiple different test frameworks, and a good chunk of different katas to inspire you to get going. And it has a wonderful sort of dashboard view, so you can see every commit that people did, every test result. You can compare what people were doing, how you can watch for the red green type progression, as people write tests, see them fail, make them pass, then do a lot of refactoring and staying at green. It's just a wonderful tool. And I'm really happy that the Cucumber company, when we still a limited company, was able to sponsor the tool. I've been very happy to act as treasurer for the charity that continues to maintain its development, and also I'm very grateful to all the businesses and consultants who do give us money on a regular basis for using the tool in commercial settings that we can then use to buy hardware to give to underprivileged kids, both in the UK and around the world. So punt, Cyber-Dojo, really good place to practice test-driven development. And that's really what you need to do. You need to practice it. It's like learning the piano. So the scale of C major on the piano is trivial. It's all the white keys. Anyone can do it. But you get a concert pianist doing it and a 5-year-old child who's just learned it. They sound very different, and they go at different speeds, and they are more or less accurate, and the timing in between each of the notes is more or less precise. And I think there's a similarity here. Practice makes us better, and it's true of everything. So why are software developers, why do we think we're different? We're not different. It's just another skill.
Yeah. Absolutely, and before we move on, I'd add my praise for Cyber-Dojo. Mine is one of the businesses that uses Cyber-Dojo to support my TDD training courses. There's a free one which I'll put a link in below, and Cyber-Dojo is just such a fantastic tool. It makes it so easy to practice test-driven development, and as Seb said, supports a wide range of different technologies, lots of different problems. It's just there in a can to practice. You don't have to do anything. You don't have to set up any environments. Just go and start using it and playing with it and adding a donation to the charity. And it's just a wonderful tool. I wish there were more things like that in the world around software development, but it's a fantastic tool. And the first time I saw John Jagger talking about the model of the little green dots and red dots and so on that describe the process, you go, oh, of course, this is brilliant. This is so wonderful, as a way of just instantly seeing when your progress is working and when it's not. Just it's an excellent tool. I'm a big fan. But that kind of practice, as you said, kind of takes you so far. It seems to take your analogy, it's like a musician playing scales, but they're not yet playing hit songs. So there's the step on to then using it, in the context of real software, and that's another difficult step, I think, in helping teams to achieve adoption. There's a recent episode of the Engineering Room where I was talking to Emily Bache about the Saman method, and about then it's using a mix of the kind of the Carter kind of approach to teaching test-driven development, and then putting it into context of people's own code bases and so on. If I'm putting words into her mouth to explain how that works.
Mm-hmm.
So what's your way of doing that part of solving that part of the problem?
Well, I don't have a generalized way of doing it, because, to be honest, I think putting things in context depends on the context. Clearly. I recall doing a gig with a company in Ireland a few years ago, and it was a telecoms company, and they had a 7 or 9 layer architecture or something, mind-bogglingly complicated. And they were going, well, we can't write that first tracer bullet because we haven't finished implementing, or they haven't even finished specifying this layer in the middle.
Yeah.
Whether they could do the basic C major scale of TDD or not is a moot point, but they were trying to apply it now to a full, the full stack, to try and get an end-to-end test, just to demonstrate that the different architectural layers were hanging together. And I just pointed out, in this situation, well, what happens if that layer just was you just put in a pass-through? You just essentially nulled it out, and it just passed the data through. So you would at least be able to make sure that all the other layers communicated. And then when the layer gets specified and you begin to implement it, you slot it in. And if it's done correctly, that test will still be working. Otherwise, it won't. Mm-hmm. And that was an insight to them. I mean, I'm not claiming there's nothing brilliant here. It's just the fact that back in when I started doing software, we thought you couldn't test software until it was complete. Hence, the test cycle was at the end. And what we've relearned over the past 30 years is that actually you can test whatever bits you've already written. In fact, you can test your ideas before you write any software. And then when you write little parts of the system that you're going to develop, that you want to deliver, you can test them, and you can test them in situ. And you don't have to test them with tightly coupled low-level tests that just exercise that part. You can test them using the domain language that you've developed during your initial discussions and when you come up with your first idea of what the design should be. And it just so happens that the implementation that underpins that high-level abstract domain language initially will just go straight to that just single component, right? But as you begin to put that component in the context of other collaborating components that are going to deliver your solution, the high-level domain concepts will in fact exercise the application from further and further away from this initial specific component that you delivered. So essentially what you've got is you've got the same language describing what you're the behavior that you expect, and you have the same central component that's implementing that business logic. But over time, it's surrounded by more and more other layers that do other things, and you just change the implementation of your top level domain term.
Yes.
So, and sometimes we think about it from the ports and adapters type architecture rather than just dealing with one component. Well, maybe we can write a specification that talks about putting pizzas in a shopping cart, and when you start, maybe it will just go directly to the shopping cart and try and add a pizza. And then when you add a database that lists the products, well, maybe it will then incorporate that. And then when you decide that you should be able to do it on your mobile phone or with a JSON call, then you will add an adapter for dealing with that. The actual specification that says you should be able to put a margarita pizza in your shopping cart hasn't changed, but the implementation of that specification has changed massively from being a hard-coded call to a cart object to being a set of collaborating components that probably gets you to log in, gets you to call the database, say what things are there available, adds it to the cart, displays it on a screen. The actual specification doesn't change, but the underpinning does. And that's the evolutionary way of working. You don't change your specification, you just evolve your implementation.
Yes, and for me at least, that seems like the real stumbling block, is the real difference between the people that seem to struggle with it and the people like you and I that find it hard to imagine another way, really, realistically, is this idea of I know you and I have both done it in the past, but I wouldn't. I wouldn't. I wouldn't do it again. but it's that idea that I don't need to, and realistically, I don't want to have to get everything right first time. I don't need to, I don't need to think really hard and build a perfect solution. I want to try stuff out. I want to learn as I'm going. I don't expect to get things. I'm pretty good as a software developer, but I don't expect to get things right. I expect to get things wrong. And so I want to do the thing that you keep referring to, evolving my solution in a bunch of small steps and get clear feedback on each of my small steps about where I am. And in the first steps, I'm not going to have an entire system in the first steps, but I'm going to work in a way as though, it's production code, even though it doesn't yet add up to anything that's necessarily useful as an entire system. And then I can add to it and I can insulate it, and making design choices that allow me that exploratory freedom seems like the challenge and the distinction between these two competing mindsets. I don't know whether that's too grandiose, but would you recognize some truth in that rambling?
Yeah, no, I absolutely do. I'm thinking to, I keep wanting to call him Dan North, but I keep thinking about Daniel Terhorst North's work on deliberate discovery. And
yes,
I'm not sure if this is his thought experiment or not, but certainly I often use it, and it goes along the lines of I have never been in a project or project retrospective with a team when they said to themselves, if we were to do this project again, we would do it exactly the same way.
Yeah.
Right? Doesn't happen. We always learn, and we learn through mistakes. The trick is working out which areas we need to learn most about, and therefore we need to have some, we need to control the hubris. And I realize that there are going to be areas of the domain or the technology in which we are woefully ignorant at the start of the project, and we need to target them and address those risks early on. And this is an approach that allows us to do this, because it says, well, we can specify the behavior, the end behavior of the product that we want based on our existing knowledge, but we don't have to implement the whole system to make sure that we learn about an area that we are nervous about, that we believe that there is risk lurking. We need to we need to work on those areas first, to surface those unknowns, to learn the things that we're ignorant of, and then evolve the system from there.
But if you'll forgive you taking my own work, that's kind of what I mean in my modern software engineering model of optimizing for learning and optimizing for managing complexities is exactly those things. Those are at the core of our discipline, it seems to me, and that neither one is more important than the other. They're both intimately entwined, it seems to me. So I want to come back to some of the stuff that we were talking about in terms of trying to help people to get there, to do these things. And when we were talking about this today, before we started, one of the things that you said that you were interested in discussing was the distinction between training and coaching, and how we should treat those. So we've talked a little bit about some of the training bits using techniques like Cyber-Dojo and so on, but fill in the detail. Tell us a little bit more about that.
Yeah. So what I've I spent a number of years working for Cucumber Limited, and sometimes as an independent consultant offering training courses. And training courses historically have been quite an easy sell because they're short time box things that purport to deliver outcomes that are tangible and valuable. Therefore, you can get budget for it. Someone's going to pay for it. Whereas coaching is you pay me to come and speak to people, and I'll wander around and we'll sit with them and we'll have conversations. It's very nebulous. Now, when I spent my time trying to help people pick up behavior-driven development, every proposal that I gave them had several layers, several different options in it. And, the top level options was training and coaching, because my experience both as a trainer and a coach, but also as a recipient of training, is that a training course courses are almost always not as valuable as people think they are going to be, because you don't get to practice what you learned. You get a huge amount of information and you'll get some hands-on stuff while you're doing it. But in the same way that you can practice the scales of C, if you don't keep practicing the scale of C day in, day out for months, you won't get to be good at it. And coaching, in my opinion, is a way of working with individuals and teams to ensure that they apply what they learned in the training on a regular basis in areas where it's applicable. I mean, a classic example of wasted time was a company that I was contracting at, and they sent all of their web developers on a training course for a new version of the framework in which they delivered their software in. But that new version required an upgrade of the Java, of the JVM, and that wasn't scheduled until that got the portfolio board pushed that out for several months. And they had a project that had been scheduled prior to the JVM update, but after the training course, they had to deliver in the previous version of the framework. Now, this is a classic, they've had the training in version 7, but we've just sent them back to do all of the development of the next project in version 6. How does that make any sense? So training is a way of getting a lot of information across quickly, and it has its uses, but until you can solidify it with practice, you are not going to get the whole value from it. And additionally, that you will find that even if you do the training course and then you go back and sit down at your desk and try to apply it, you will find that contextual questions come up, no matter how good the training was, that you can't answer on your own. And that's where the coaching really comes in. You have somebody who's experienced in a specific area that the team wants to get better at, but has a wider breadth of experience and knowledge, so that they can see areas where the material from the training course can be applied, but also areas where it can't be applied and where other techniques might be appropriate. Because another challenge that we have, not just in software, but in pretty much any walk of life, is that we, for someone with a hammer, every problem seems like it's a nail. And so if you go to a training course and, for instance, we're talking about TDD, well, we might try and TDD, a templating library, and we actually go down and try and write tests around the library that we've just borrowed in from somebody else. This is not a great idea. You might have mentioned it in a 3-day TDD course. Oh, don't try and write TDD tests around, automated code generation from frameworks that you don't own. But then you get back, and that's where you're working as in your day job, and the temptation, you maybe just forget that, and the temptation is to write inappropriate tests. So coaching is the thing that actually turns the training into valuable skills that can be delivered to help the business achieve its ends. Whereas training on its own often goes to waste, and coaching on its own can be valuable, but you need to, if you want just coaching, then you probably need to have a scope, an area of work that the team or the individual has identified as somewhere that they want to improve on, or that they think that they have weaknesses.
Yeah, I think that's a really good description, and it makes me think about one of my other bugbears, my many bugbears about the software industry, which is that many organisations don't value learning in their teams. You were talking earlier about the organisations hiring developers and wanting to hit the ground running and all of those kinds of stupid rock star kind of promotion ideas in recruitment. But I've been fortunate to work in a handful of world-class development teams through my career, and I think that's a lot during the course of my career. And all of them, all of the best developers I've ever worked with, are completely obsessed with learning new things, developing their skills, being humble about the knowledge that they have and want to gather more, and helping other people. I often in the back of my mind think about Fred Brooks talking about this in the Mythical Man Month in the 1970s, about his idea of surgical teams. You have a very experienced person, a mid-experienced person, and a junior person on a team working together and supporting one another. And it's not just that the junior person's learning from the expert, they're all learning from one another. And that kind of coaching is certainly the hallmarks of the world-class teams that I've worked on, that kind of mutual support and learning going forward all of the time. My most recent version of this world-class team was LMAX, where we built financial exchange. And I can remember being floored by questions from the most junior member of the team. And you just go, hold on a minute, I don't know the answer to that. Why is that? Why are we doing that stupid thing? That's a really, how could we do it better? And being open to both supporting one another seems fundamentally part of the job, but also open for organisations to support that kind of idea of internal coaching. This is not necessarily hiring external people like you and I to try and sit next to teams. It's more that philosophy of learning again, it seems to me.
So there is a sort of, I don't know if it's a subtlety, but coaching itself, I don't have any coaching certifications, but I have spent a lot of time watching coaches and reading about coaching, and practicing coaching. And coaching, it's quite hard, because you need to understand the power dynamics between you and the person that you are coaching, and there's some stances that you can take. The Socratic approach to coaching is generally the way I work, which is asking questions, open questions back to encourage the coachee to consider their position. If you just put junior and senior, a mix of people together, you can end up with a slightly more restrictive pedagogy, where the experienced person goes, no, you must do it like this, and is incapable of explaining it, and doesn't give the coachee the space to actually think their way into the problem.
Yes, no, absolutely. It's a distinct set of skills. I think my own view is that the best coaches will both be very skilled at what it is that they're coaching, as well as having coaching skills.
Yeah,
you can't either one alone isn't enough.
Yes, and this is so. For instance, this is why it's really hard to find a technical agile coach, because technical people often don't have the softer skills that a lot of agile teams are looking for, and agile coaches generally don't have many technical skills. And so what we end up with is a lot of ceremony coaching, and then technical stuff is DIY. You either read the books or watch the online videos or go to training courses.
Yeah.
It's hard to find people with both those sets of skills. And when I was working at Cucumber, we tried to develop, we tried to enlarge our pool of people that could deliver our course. And we found that very hard because you need to both be a trainer and understand behavior-driven development and also understand the implementation of, the language bindings of Cucumber. And that takes quite specific people. And it's a vanishingly small group of people who actually have acquired all those skills.
Yes. Let's move on a bit. One of the other things that I saw recently from you, I think, one of your recent talks, you were talking about contract testing and PACT, and I really liked your presentation, and one of the ideas that stuck with me, that resonated, that you mentioned naive approach and decoupled approaches to thinking about the contracts between different services. Could you just cover a little bit that, and in particular maybe touching on I think something, a view that we both share, is that microservices is one of those really good ideas more frequently practiced in the breach than the observance.
Yes. Yeah, so I mean, the idea of contract testing, again, is that it's not really about testing. Again, just like TDD isn't really about testing and BDD isn't about testing, the contracts are about trying to specify the dependencies between components in a way that is both understandable to the people who need to understand them, but is also enforceable, or at least checkable by software, so it can be the compliance can be automatically discovered. And one of the challenges is that in the microservice environment ecosystem that we live in at the moment, you don't just have component A talking to component B. You've got chains of interaction and chains of dependency. And the challenge is, maybe we're skipping ahead a bit too quickly, but the challenge in the microservice ecosystem is that the promise of microservices is that each microservice should be independently deployable, rather than having to naively release multiple microservices in lockstep. And one of the challenge there is that if you have got a pipeline, as your wonderful book, which I see on the shelf behind you, talks about, then you'll have different versions, potentially have different versions of each component in each environment of the pipelines, and you want to run the tests to ensure compliance as the component moves its way through, from doing unit tests, for instance, all the way through to deployment and making sure that it works in live. And now we've got a lot of, it's not just one component talking to another. It's not just one component potentially talking to many other components. It's a version of a component that has to work with many other components that might also be in many other versions. And we've got a cross product going on here. And quite quickly, it becomes mind-bogglingly complicated to try and visualize it for a human. Not so difficult for a machine. And this is where PACT really excels. So PACT, which is a free open source piece of software, ships with a component within it called the PACT broker, which essentially tracks each version of each component, what its dependencies are on other components, and which environments each version has been deployed in. And you only have to run the contract test between component A version 73 and component B version 212 once, and now you can say that whenever you are about to promote component A into a new environment, you just check, have I run a test with this version of this component against the version of the component that it depends on in the environment I'm just about to deploy it to. So you don't have to run the test at the point that you want to do the deployment. You just have to look up in the broker's matrix, what was the result of that test? And if the test is it passed, then it's for the purposes of that dependency, it might be safe to promote. And then you scale it up to multiple dependencies and many components, and you get a very, very quick way of being able to ascertain whether it's safe to promote any given version of a component into a specified environment. And that's a major win. Beth Scurry, who's one of the developers, original developers of PACT, has a wonderful saying, which is, if you can't promote a microservice independently of other microservices, you don't have microservices. What you've got is a distributed monolith. And there's nothing wrong with a distributed monolith. It's just it doesn't deliver some of the beneficial properties that a microservice architecture promises to people. And so there are many organizations who've jumped head first into microservices, maybe without understanding all of the constraints about them, but certainly without understanding the need to be able to treat each microservice as an independent deployable that can be evolved, promoted, and deployed without having to worry about changing other ones. If you're introducing a breaking change, you want to know that you've introduced a breaking change, and then maybe you do have to deploy them at the same time. But as your book lays out in some of the pattern sections, there are ways of keeping backward compatibility and then phasing it out later. So I'm not sure. Is that what you wanted? Is that the question you wanted me to answer?
No, that's perfect. Thank you. And it's perfect on multiple fronts. In that it's really understandable. You've talked about a new project, and you're reinforcing my prejudices. So it's ticking all the boxes. I agree entirely. I often talk about. I'm a fairly strong proponent of a distributed monolith in the right circumstances. It has some nicer properties. It makes dependency management a lot easier for some kinds of systems than microservices do. But microservices have some wonderful properties, and you need to architect your system to get the gains that you want to get rather than just following a fad.
Well, so I think Matt Wynn did a talk, it must be a decade ago now, called mortgage-driven development. Basically, it was a satire, right? So nobody listening should take it seriously. But where you practice a particular skill because it'll look good on your CV and it'll get you another job later on. It's at risk of being one of those at times. But and contract testing is certainly an important part of the answer. I think the other thing that we've alluded to throughout our conversation is the idea of more deliberate design, thinking about what those contracts are and abstracting appropriately to reduce coupling to a sensible level, a sensible manageable level, and that gives you then opportunities to mitigate the chances of a change in one part of the system adversely affecting another, and your contract tests can, if they're good, can detect the times when you get that wrong. I'm very conscious that we are running out of time, and I know that you've got things to do. There's one thing I don't know whether you've got 2 or 3 minutes on expert advice and its pitfalls. I liked the sound of that when you mentioned it as a suggested topic to talk to. So it's a session that I've been doing for a few years now, and I use agile examples from the agile sphere to point out that So you and I, depending on who we're speaking to, we're considered experts. And when we say something, people potentially, the two things can go wrong. One is they misunderstand what we say, and the other is they don't misunderstand what we say, but they don't take it in a context-sensitive way.
Yeah.
I use, one of the examples I use is I wasn't prepared for this, actually. So I'm thinking about
sorry.
to think back to the talk that I was giving. There is an acronym that is used for good user stories, and I know exactly what it is, and I can't remember it now. Can you help me?
Invest.
Invest. Thank you very much. It's the Invest acronym, and so one of the things that it talks about is independent.
Yeah.
And well, independent is an English word. It should be easy to understand. What does that mean? Well, independent doesn't mean that the story is completely separate from everything else, because the whole idea of user stories is that they incrementally build on top of each other. Independent really means that you shouldn't have to deliver two stories in parallel at the same time. So they could be independently deliverable.
Yeah.
That's not explained clearly. And so people quite frequently, that then leads teams to think, well, this story builds on that story, so they're not independent, so we should merge them together. And then you end up with massive stories.
Yeah.
And the same thing goes, you see the same thing over and over again. Story points has the same problem. There are all sorts of spheres where people come up with nice ways of communicating a simple concept for people who are learning. And then that explanation gets the weight of something that's been handed down on a tablet on top of a mountain, and it must never be contravened. And so the point of my session is to demonstrate that there are multiple things that everybody in the audience is very familiar with, that they've heard number of times in the past, and that are very useful in many situations. And yet there are situations where they are not just not useful, but positively damaging. And I then I segue into the fact that really what we're looking for is more of a pattern form of communication. So I'm not sure whether many people listening to this have gone beyond, the head first design patterns type books or the Gang of Four, but the whole patterns movement was started by an architect called Christopher Alexander back in the 70s or maybe in the 60s, and he came up with
a building architect.
A building architect, yeah, exactly. And he came up with a pattern form which talked about the context in which a pattern was applicable and the resulting forces, as in what the resulting context looked like, and therefore if you apply this pattern in this context where it's applicable, well, there are some limitations to how you can then proceed, because there are some results of applying that context. And I think that most of our expert advice doesn't come with enough context, both is this pattern applicable, and also what constraints or what the ramifications of applying this pattern. And so the conference talk, and I'm not sure if it's been recorded actually, but the conference talk, when I give it, the idea is to give people sort of belly laughs about how you can misunderstand, really quite popular acronyms or diagrams or heuristics, and then to show that there are contexts in which they are appropriate and contexts where they're not, and there are contexts that the outcomes the outcomes of applying them are beneficial, and others where they're not. And so if someone is giving you advice and they don't give you the context in which it's applicable, and they don't tell you about some of the ramifications of applying it, then caveat emptor, as they say, buyer beware. Any trouble that you have, I'm afraid, is your own. But the problem is that we have a culture of experts. We've got Stack Overflow, we've got we've got your YouTube channel, we've got my books, etc. They all have contextual limitations.
Absolutely, 100%. I shall go and look up that conference talk. I hope it is online somewhere, and if it isn't, record one and tell us.
I will try and do that. Thanks, Dave.
It sounds like fun. So I think the summary of our conversation, from my point of view, is probably it's complicated.
Yes.
It is. I like that about software development. It is complicated.
Well, I mean, we're no longer writing little basic loops that go, "Hello, what's your name?" Like,
Yeah.
Seb. Hello, Seb.
Anyway, I feel like we should wrap up. It's been an absolute delight talking to you today. Thank you so much, Seb, for agreeing to doing this. It's been a lot of fun, and I've enjoyed our conversation a huge amount.
Thank you, Dave.
It's a pleasure. I say once again, thanks to Equal Experts for sponsoring this. If you've enjoyed watching this and you've got this far, please do hit like. And if you're not already a subscriber to the channel, subscribe to the channel. We've got more content like this. Thank you very much, and bye-bye.
Bye-bye.